All right, welcome to 1.3, which is on estimating square roots. I believe that we did this last year. So, nice review for you here. Okay, so my first question for you is, what's the exact answer to the square root of 18? Now remember, what that means is we're looking for a number that multiplies by itself and gives you 18. I can't think of anything, like there's no whole number that works, so how are we going to do this? Well, I know what we could do. What do we have at our disposal? We have calculators. So why don't we go to our calculator, here's one, and find the square root of 18. And there's the answer right there. Oh, wow, look at how exact that is. 4.242640687. Wow, look at all those decimal places. That must be very exact, right? No, that's not right. How come? Because there's actually more decimal places after this. All right, let's get more. So I go to a different calculator. I'm going to this advanced calculator, and I want to find the square root of 18, execute, and I get my answer here. Whoa, look at all these decimal places now. Just add those on there. Gosh, that's got to be exact now. Look at how many decimals there are. No, not exact. How come? Because there's more decimals. How many are there? It's endless, people. They go on forever. You could keep writing decimals for the rest of your life and you still won't have the exact answer. Now, are we close? Sure, we're really close to the exact answer. But we literally cannot write the exact answer in decimal form for this question. So note you would write, actually, if you were asked what is the exact answer to root 18, the exact answer is root 18. In future grades, I'll get you to write that. Although, we will have you simplify them. You're going to learn something called simple radical form. You want me to give you a 20 seconds explanation? 18 can be written like this. 3 squared times 2. 3 squared is 9 times 2 is 18. If we take the square root of all that, because that's what we're doing with square roots, we could also just take the square root of the first one and multiply it by the square root of the second one. But wait a minute, if you square something and square root, remember those undo each other? So this first bit right here is just equal to 3. But there's nothing you can do to the root 2, so that stays there. This is actually root 18 in simplest form is 3 root 2. But root 18 is also exact. This is exact, this is exact, this is not exact. This is just an estimate. So don't worry about this if this confuses you, right? My point here is that when you use a calculator for square roots, it's not giving you exact answers. Unless it's what kind of number. What if it was a perfect square and you used a calculator? Well, of course you're going to get an exact number because the answer is just 4. And your calculator can handle that. Alright, that takes me to this idea. There are two types of answers to square root questions. One type are rational numbers. And we mentioned this quickly before. Rational numbers are numbers that can be written as fractions. Like this number 4. That can be written as a fraction, 4 over 1. So this is a rational number. But this number, this decimal that goes on and on and on forever, that is not a rational number. It can't be written as a fraction. When are you going to get these rational numbers as your answers? You're going to get an answer like this, a rational number, when the radicand, the number in here, is a perfect square. If it's a perfect square, you're going to end up with a whole number or a rational number. Now, the other type of answer you're going to get are irrational numbers. That's like this thing, this 4.2426406, blah, 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 and remember it goes on and on forever. So irrational numbers are decimals that go on forever, like this decimal up here is going on and on and on, but it's never repeating. It's just a random sequence of numbers with no pattern to it. When are you going to get those irrational number answers? Well, when the radicand is, 18 here, is not a perfect square. If it's not a perfect square, you get these crazy decimals that go on forever. If it is a perfect square, you just get a rational answer. It stops. Okay, so that takes us to how are we going to estimate square roots when they're not perfect squares. When they're perfect squares, we don't need to estimate. We can get exact answers. How do we estimate square roots? Well, one thing we can do to estimate is we can use a calculator, right? This answer up here, this 4.242.6, this isn't exactly what it equals, but it's very, very close to what the square root of 18 equals. So here's what we can do. Rather than saying that the square root of 18 equals this, you can put two symbols here. You can put the dot on top. That means is approximately equal to. Or you can do the wavy thing. That also means is approximately equal to. Okay, so we could use a calculator to estimate square roots. The other thing you could do is you could use a list of perfect squares. And that's what we're going to do here. I don't know what I had planned for this big space here. So here's a list of perfect squares. We've talked about these numbers before. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, all the way up to 15 times 15 is 225. Of course, this list keeps going on and on. These are the ones I really think you should become familiar with. So we're being asked, what's the square root of 18? Now, I know we have the answer right up here, more or less, but I just want to show you how you would use these numbers here to figure it out. Okay, the square root of 18. Well, if the question was the square root of 1, we could easily do that. If this question was the square root of 4, we could easily do it. Square root of 9, square root of 16, square root of 25. But we don't ask any of these beautiful numbers here. They ask square root of 18. Okay, well, where would square root of 18 land on this list of numbers? It would sit right here, right? Square root of 18. Well, that's useful because now we can just focus in on these two perfect squares here. What's the square root of 16? What multiplies by itself to get 16? 4. Square root of 16 is 4. What's the square root of 25? What multiplies by itself to give 25? 5. All right, well, if the answer to square root of 16 is 4, and the answer to square root of 25 is 5, then the answer to square root of 18 must be between 4 and 5. It must be 4 point something. Now, when we estimate these things, we're not going to estimate them to 3 decimal places or something. That's impossible. You can't estimate them like that unless you're estimating with a calculator. But for the rest of this lesson, I'm talking about when you're not using a calculator. No more calculators in today's lesson. So, we need to do 1 decimal place here. So here's what you do. You ask yourself, this 18, is 18 closer to 16 or to 25? Well, it's closer to 16, isn't it? It's only 2 away from 16. It's 7 away from 25. So it's definitely closer to 16. It's closer to the smaller amount. So it's going to be closer to 4 than it is to 5. So what does that mean? It means our answer, our decimal here, has to be less than 5. Our answer must be less than 4.5. Because if it was 4.5, then it would be right in the middle between 16 and 25. But this is closer to 16, so it must be less than 4.5. And in fact, it's quite a bit closer to 16. I think the best answers for this would either be 4.1 or 4.2. Either one of those I would mark correct as an estimate. Now the actual answer we know is 4.24. So actually, you know what? 4.3 is actually not a bad estimate as well. That's usually what I do is I'll give you 3 possibilities as your answer. Not always, but usually. Okay? Great. Let's do some more. But first, I'll give you the steps because I know some people love writing down steps. Step 1. Figure out which 2 perfect squares the radicand falls between. So maybe I'll just show you in the next one right here. We have square root of 27. So which 2 perfect squares in our list, which I have very handily included for you again over here, which 2 perfect squares does it fall between? I'll try to be neater this time. 27 falls between 25 and 36, doesn't it? Okay, great. So how does that help us? Because this is going to help us to determine the number in front of the decimal in your answer. Is that confusing? Okay, let's go through it. Because we know it's between 25 and 36, that's great because we can take the square root of those numbers easily. What is the square root of 25? The square root of 25 is 5. We already talked about that. What's the square root of 36? What number multiplies by itself to give 36? 6. So since 27 is right between them, or somewhere in between them, we know the answer must be between 5 and 6. In other words, it's going to be 5 point something. It's always going to be the smaller number that goes in front of the decimal. It'll never be 6 point something, otherwise it would be bigger than this. In order to be between 5 and 6, it has to be 5 point something. Okay, next step. Figure out whether the radicand, that 27, is it closer to the smaller perfect square, which in this case is 25, or is it closer to the bigger perfect square? Well, 27 is definitely closer to 25. So again, since it's closer to the smaller one, our answer has to be less than 5.5. I would probably give the same options I gave last time. 5.1, 5.2, 5.3. I'd probably eliminate 5.1 personally, but I would mark any of those correct. If you're interested, the actual answer is 5.19, so it actually rounds up to 5.2. But don't worry, I would mark any of these correct right here. Okay, next one, square root of 80. So, first step, where does the square root of 80 fall between? Well, it's just a little less than 81, but it's definitely bigger than 64. Why does that help us? Because we know what the square root of 64 is, and we know what the square root of 81 is. What multiplies by itself to give 64? 8. What multiplies by itself to give 81? 9. So what's that mean for our answer, for our estimate here? It has to be 8 point something. So I can already write 8 point something. Now, is our radicand, the 80, is it closer to 81 or 64? Whoa, 80 is really close to 81, right? It's almost this high. So our answer must almost be equal to 9. So don't put 8.1 or 8.2. That's not close to 9. I would only accept in this one 8.8 or 8.9. Even 8.7 just seems too small to me. And in fact, the answer is 8.94. So definitely 8.9, but I would accept either of these two answers. All right, once you get the hang of it, they're all kind of the same. Square root of 40. So first thing you want to do, which two perfect squares does 40 fall between? Bigger than 36, smaller than 49. Why is that good? Because we know what the square root of 36 is, and we know what the square root of 49 is. We've already done 36. It's 6. What's the square root of 49? 7. 7 times 7 is 49. What does that mean for our answer? It has to be 6 point something. Okay, is 40 closer to 36 or 49? Well, 40 is 4 more than 36 and 9 less than 49, so it's closer to 36. It's a little bit closer, not dramatic, but a little bit closer. So it's closer to the smaller one. We know it has to be less than 6.5. I'd probably say 6.2, 6.3, maybe 6.4. Any of those answers are good. The actual answer is 6.32. You see how I'm only estimating to one decimal place. It just wouldn't be possible to go more than that with this method we're using. All right, last one of these ones. Square root of 180. Where does that fall? Bigger than this, bigger than this, bigger than this. Oh, smaller than that. So somewhere between 169 and 196. So we know the square root of 169. We know the square root of 196. Well, you might not, but there. You know how you can figure it out if you don't know what it is? Just count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We got this one by doing 13 times 13. So the square root must be 13. And obviously the next one is going to be 14. So our answer to the square root of 180 must be 13 point something. Now, 180 in here is how far away from 169? It's 11 away from 169. It's 16 away from the bigger one, 196. So again, I've done too many that are closer to the small one, but it's also closer to the small one again. So again, I'd probably do 13.2, 13.3, 13.4 as my estimate. Pick one. You don't write them all down. Pick one of those three answers as your estimate, and I would mark it right. Actual answer, 13.41. All right, estimating cube roots. Guess what? It's exactly the same. The only thing different is we have a different list. You're not going to use this list of numbers because this is the perfect square list. You're going to use this list of numbers because it's the perfect cube list. So we do the same thing, cube root of 14. So the first thing we're going to do is looking at this list right here that I just erased, where does 14 sit? 14 falls between 8 and 27, sorry. So why is that good to know those numbers? Because we know the cube root of 8 and we know the cube root of 27. What number multiplies by itself 3 times to get 8? 2. Well, look, it's the second one over. It must be 2. 2. 2 times 2 is 4. 4 times 2 is 8. Which number multiplies by itself 3 times to get 27? 1, 2, 3. 3 times 3 is 9. 9 times 3 is 27. So we know our answer is 2 point something. So 14. 14 is in the middle. Oh no, don't tell me I've done it close to the small one again. 14 is 6 away from 8 and it's 13 away from 3. So again, it's closer to the smaller one. I'd probably go with my 2.2, 2.3, 2.4. You pick one of those, whichever one feels best to you, and you'll get it right. Actual answer is 2.41. And the last one, cube root of 92. 92 falls between which two perfect cubes? Between this one and this one. Ooh, this one's going to be hard. So we know the cube root of 64 and we know the cube root of 125. Number that multiplies by itself to give 64. When you multiply by itself 3 times, that is 1, 2, 3. It's 4. 4 times 4 is 16. 16 times 4 is 64. Number that multiplies by itself 3 times to get 125. It's 5. 5 times 5 is 25. 25 times 5 is 125. So we know our answer starts with 4 point something. Okay, so 92 sits somewhere in the middle here. So what's the difference from 64 up to 92? That is 28. What's the difference from 90? No, I've done it again. Put it closer to the smaller. Why? The difference from 92 to 125 is 33. So it is closer to the smaller one, but not very much this time. Here's one where I think I'd accept 4.3, although I think that might be too small. 4.4, and I'd even accept 4.5 because it might round up to 4.5. And in fact, it is the case that it rounds to 4.5. All right, everyone, take care.